Okay, this is a continuation of 5.02, 5.03, whole group. This is mostly whole group 2 or 1 or both, either way, mostly 2. But we didn't get to finish in order of operations and exponents. We got through most of the exponents, so this is the end. We're saying cubed. What does cubed mean? And some people are like, well, what are all those extra numbers? All I'm trying to say is, before you even look at this down here, just look only at this. Matter of fact, I'm gonna darken that even more. Just pretend like it's not there. It's not there. It's not there. It's not there. It's gone. It's gone. So when we're left with the top part here, we're saying 2 raised to the 3. What that means is we have this 2 here. I'm gonna make it blue. We have a 2, 2, 2. We have that 2. How many times do we have the 2? We have it 3 times. That's why there's 3 of them. And this is repeated multiplication, 2 times 2 times 2. And if you were to do this, you have to go left to right. You say 2 times 2 is 4, right? So what I've done so far here is in the red, I've turned that into this. I still have the green left. I still have to multiply it by 2. So what's 4 times 2, right? This is my green that's left over. 4 times 2 is 8. So what we're saying is this comes from a cube, right? It comes from a cube. Like everything's the same. This is 2. If this were 2 and the height were 2, what would be the volume of the cube? Kind of look like this maybe. How many little cubes would be inside of that? If you could see it, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. Yeah, and a Rubik's Cube, how many cubes are inside of that? I think that's a 3 by 3. I think that's one of these, isn't it? Rubik's Cube, I'm pretty sure. Because it has like 3 this way, 3 this way, up and down. So how many cubes are in a Rubik's Cube? Uh-huh. Yep, that would be this, 3 times 3 times 3. This time we're saying we have the number 3, the orange 3. So I'm going to do this in orange. Oh, first I'll put it in black and then highlight them in orange. 1, 2, 3. See the orange 3s? How many orange 3s do we have? 3 of them, 3 copies. That's what this green 3 means. Make 3 of them. So now we're going to do 3 times 3 times 3 because this is repeated multiplication. 3 times 3 is 9. We still have another 3 there. So 3 times 3 times 3 is 27. You would have 27 cubes in a Rubik's Cube. It's 27 cubes, or 27 units if you're talking about other things. Okay, so that's what this is all about. So just to clarify, this 10 to the 3, that means you have 10. How many times do we have that 10? 3 times. So it would be 10, 10, and 10. There's 3 of those 10s. 3 copies of it. And we're going to multiply them together. What's 10 times 10? That is 100. Well, we still have to multiply by this 10, and that equals 1,000. What if this weren't a 3? What if this were 10 to the 4? Then that would be 10 4 times. 10, 10, 10. There's 4 copies of it. I want to make it orange. So you see this orange? The green power here, or exponent, tells us we have to have 4 10s, 4 of the orange 10s. 1, 2, 3, 4. This is repeated multiplication. So it's 10 times 10 times 10. Well, 10 times 10 times 10, we already did that. That's 1,000, right? All right, so if we add one more 0, that would be 10,000. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Yep, there you have it. Quick check. Type 3 squared in the chat. 3 squared. I meant like this. But you guys in the chat would probably do 3 caret. Oh, 3. I call it a caret. 2. 3 raised to the 2. 2 cubed would be 2 raised to the 3, or 2 raised to the 3, or 2 to the 3rd power. What is 3 squared? 3 squared is like like this. That's 3 times 3. There's 2 copies of it. That's going to be 9. 3 times 3 is 9. What is 2 cubed? 2 cubed. So has a 3 on top up here. So we have 2. How many times do we have the 2? We have it 3 times. So that's going to be 2 times 2 times 2. 2 times 2 is 4. We still have to multiply it by this 2, which is 8. Evaluate to find the value. See, a value. evaluate of an expression. Other terms could be express, simplify, write in expanded form, and also equivalent. Did I put equivalent? Also equivalent. It might say, what's the equivalent of? What's the equivalent of 9 to the 3? One of the answers might be 9 times 9 times 9. That is, these two are equivalent. They're equal to each other. Normally you wouldn't see it that way. So I'm going to kind of just fix this for a moment here. Normally you would see it more like this. I get a little sloppy sometimes. Oh, let's be honest, I get pretty sloppy sometimes. There we go. So exponential form, here it is. Expanded form like this. Exponential, expanded, exponential, expanded, exponential, expanded. See, 3 to the 5th is expanded. Let's try another one. Let's do 4 to the 2, expand. Oh, here we go. Expanded, 4 times 4. Value, this is what I call standard. What's the standard way of writing that? That would be 16. 4 times 4 is 16. That's the standard way of writing that. So let's go to the next one. 2 to the 4th. That means we have 4 copies of the 2. 1, 2, 3, 4. And it's repeated multiplication. Remember, the dot means multiply. 2 times 2 is 4 times 2 is 8 times 2 is 16. What? Did I mess something up? Is that possible those two could be the same? Let me try that again. 2, 4, 4, 4, 16. 2 to the 4. 2 times 2 is 4 times 2 is 8 times. That just happens to be quite the coincidence. That's not always going to be the case. Matter of fact, let's find out. If we flip it here. Oh, I just realized I'm flipping them. I switched 4 and a 4, 2 and 2, 5 and a 5, 3 and 3. We think it's going to be the same this time. Let's try 5, 5, 5. 3 copies of the 5, the base. Multiply. 5 times 5 is 25 times 5, 125. Is it going to be 125 for this one? Now we have 3, 3, 3, 3, 1, 2, 3, 1, 2, 3, 4, 5 threes. Yep, remember this 5 means we have 5 of these threes. 1, 2, 3, 4, 5. Repeated multiplication. Repeat to remember. Remember to repeat. So 3 times 3 is 9. Now I got to do, I'm just going to do it this way. 9 times 3 is 27. 27 times 3 is, I don't know. 27 times 3, that's 21. 6, 7, 81. 81. 81 times 3, and that's our last one, is times 3, 3, 24, 243. Wow. So yeah, not the same. That was a coinkydink up here, coincidence, that these two are the same, because they're not always going to be the same. Careful. When I first did this, I did it like this. Last year I went like this. I went. And then I drew the rest of the picture underneath and said, oh, no, it's not a shark. It's somebody who has a shark hat on. Oh, silly people. But be careful anyway. Be careful of this. 2 raised to the 3. Right away. I said, hurry up. What's the answer? Who can get it the fastest? 6. Is that right? Yeah, no. Because what happened? We did 2 times 3, right? And we got 6. 2 times 3, but that's not true. Really, see, not true, not true. What we're really saying is it's like this. Let me just kind of erase this mess from the other lesson I was doing. See, it's really going to be, again, 3 copies of the 2. So we're going to have that 2 3 times. 1, 2, 3, but you're going to multiply them. And it goes like this. 2 times 2 is 4, and 4 times the 2 that's left is 8. Okay, which one of these is 3 raised to the 2, or 3 to the 2nd power? Feel the power. Okay, it's this one. Dun, dun, dun. Different ways to write 5 to the 3. Exponential form is just 5 to the 3. Word form is, you can just say 5 to the 3, or you can say 5 to the, probably more properly is 3rd power, but I get kind of lazy and I just say 5 to the 3. Expanded form would be 5 times 5 times 5. Standard form would be, see, 5 times 5 is 20, is 125. Also, I call that the value, but these are all values, really. So value is probably not the best way to do that. Probably standard form would be. What's another way to write 5 to the 4? Try it. Expanded form. Expanded form. Expired. Expired. That's where I keep getting that from the Google commercial. The ants. The ant that comes to the house. Expired. 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 So it'd be 5, 5, 5, 5. How many? 4 of them. There are 4 5s. See? This tells us how many there are. The exponent tells us how many. The base tells us of what? 1, a 2, a 3, a 4. And we're going to repeated multiplication. All right, so you get the idea. We're not going to do those. Ooh, this one's a fun one. See if you can figure this one out. If you're in whole group 1, you already did. You got it? You can pause the video, you know. Okay, so we have 8, 8, 8, 8, 8. Remember, it says all expressions. Select all, so there's more than one. So how many 8s are there? 1, 2, 3, 4, 5. So the 8 is the base. And the exponent is how many I have of those. I have 5 of them. So right away I can see A is a good answer. What about B? B is really 8 to the 1 and 8 to the 5. It's really, because if you have 8 to the 1, that's 1 8. And you have 5 more 8s. 1, 2, 3, 4, 5. So here's 8 to the 1. Here's 8 to the 5. You have 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5. You have 6, a total of 6. We're only saying we have 5. So it can't be this one. This is 8 to the 2 and 8 to the 3. 8 to the 2 and 8 to the 3. 1, 2, 3. See what I'm doing here? I'm taking this 8 to the 2 is my orange. 8 to the 3 is green. I end up with 5. That's an answer. That one counts as an answer. So we have A and C so far. What about D? 2 to the 3. That doesn't look like anything like that, but let's just make sure. 2 to the 3. And we have 2 to the 3. Oh my, it's a power raised to the power. This is a lot of power. This is really powerful. So it's 2 to the 3. So we're going to treat this like the number here, and this is going to be our green. So how many 2 to the 3s do we have? We have 5 2 to the 3s. All right, so 1, 2, 3, 4. We have 5 of those. So that's going to be 2 to the 3, 2 to the 3, 2 to the 3, 2 to the 3. Now I'm going to break it down again. What is 2 to the 3? 2 to the 3 is really 3 2s, 3 of the 2s. So I'm going to write that 2. Whoop. This is really 2 times 2 times 2 right here. What is 2 times 2 times 2? Isn't that 2 times 2 is 4 times 2 is, it's 8. So each one of these is 8. Oh my gosh. So really, this is 8, 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 this is 8 times. How many 8s do we have here? A 1, a 2, a 3, a 4, a 5. That's also a valid answer. It's equivalent to. And how about the last one? Is that also a valid answer? We have, see, we do this first. 2 to the 3 first, which that is 8. Now we still have that 5 here. So what is 8 times 5? 8 times 5 is 40. And that is not the same thing as 8 times 8. Because if you do 8 times 8 right here, you're already at 64, which is way more than 40. Take 64 times 8. Take whatever that is times 8. Take whatever that is times 8. You got a big number. I don't know what it is, but it's big, way bigger than 40. So that's not an answer. There you go. Which value is equivalent to 4 to the 5? This one shouldn't be so bad because here we have, try it first. Did you pause? Pause. What are you waiting for? Pause. Pause the video. Okay. You're back? Oh, you're back. Sorry. Okay. All right. 4, 5. We have, how many times do we have that for? 1, 2, 3, 4, 5 times we have the 4. 1, 2, 3, 4, 5 times. Oh my gosh, this is a big number. 4 times 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is, oh, this looks like a cool way to do it. I have to do it over here though. 16 times 4, 24, 4, 64. What's 64 times 4? I'll put that answer here. Times 4. Look at that. I'm just going to continue right where I left off. 4 times 4 is 16. 24, 25, 256. Oh, one more to go. What's 256 times 4? Put that answer right here. I'm running out of space. That's okay. I can move it up. Oh, just kidding. Let's try that again. Not you. I want to move the numbers, not the background. There we go. Okay, times 4. 24. 4 times 5 is 20, plus 2 is 22. 4 times 2 is 8, plus 2 is 10. What do you know? Bum, bum, bum. That's a big number. Evaluate. Try it. That would be 10 times 10, which is 100. Evaluate. That would be 10 times 10 times 10, which is a 1 with 1, 2, 3 zeros. 1, 2, 3 zeros. 1, 2, 3, 1,000. That's because 1 times 1 times 1 is 1. Okay? All right. Evaluate 10 to the 1. That's only 110. There's nothing to do there. Just put a 10, you're done. What's 10 to the 0? Ah, that's a tricky one. 10 to the 0, 10 to the 0. All right, let's try this. I'll show you how it works. Ready? We're going to look at a pattern, see if we can use the pattern to help us figure out what 10 to the 0 is, okay? I'm going to pause. I'm going to do not disturb just for 20 minutes, my Zoom, so we can finish this video. Where were we? Here we go. Expanded form. So that's exponential form. If we write it in expanded form, that's a 10 with 5 zeros. Or, no, I'm sorry. That's going to be this. That's the standard form. Standard. Standard is 10 with 5 zeros because there's 1, 2, 3, 4, 5 of these 10s. Okay. Here we have how many 10s? 4 of them. How many zeros? Ooh, so this is 5 zeros. This is 4 zeros. 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 Okay, 10 with 3 zeros. 10 threes, 10 with 3 zeros. So we got 5. Oh, you see the pattern? 4, 3. What's going to be next? 2 zeros, right? 10 with, is it a 10 or it's a 1? I'm sorry, it's a 1 with 5 zeros. A 1 with 4 zeros. A 1 with 3 zeros. Yeah, there we go. This would be a 1 with 2 zeros. There it is, a 1 with 2 zeros. And then what's this? What's a 10 with a 1? That's a 1 with 1 zero, which is just 10. A 1 with 1 zero. So it's 5, 4, 3, 2, 1. And then what's next? So what is 10 to the 0? Based on the pattern, what would be next? You got it? Yeah, a 1 with no zeros. So what's expanded form? Also a 1 with no zeros. So now you know 10 to the 0 is always 1 right here. 10 to the 0 is always 1. And 10 to the, or anything to the 1 is whatever that anything is. You know, for example, what's 27 right here? 27 to the 1. That's going to be, if you haven't guessed it yet, 27. All right, just for fun, what if I said what's 1 million to the 1? 1 million. Running out of space. Okay. How about 27 to the 0? 27 to the 0 is 1. It's still 1. Can you believe it? Because there's, yeah, it's crazy. 275 to the 1. 275 to the 1 is 275. How about 275 to the 0? 275 to the 0. I like this one because it's 1. I like this one because it's 1. All right, so we got that. So we learned how to write expressions with exponents that represent real world situations. We didn't get too much in the real world situations part, but we did kind of. We're talking about cubes and squares and stuff, and that's definitely real world stuff when you kind of measure like your house floor area or your yard, how many acres and when you're packing things up, that's that volume piece there with cubes and things like that. But now what comes next is evaluate expressions, multiple operations, exponents, using exponents and symbols, grouping symbols. We're going to pretty much just work with what we call parentheses, these thingies here. Be right back. Okay, I'm back. It's like I never left, right? For you, I didn't. But for me, I had to go teach for a while. But here we go. Speaking of teaching, this is a story about two mathematicians who are trying to figure out how they should agree upon how to do a problem. But this one, they didn't have any issues. The one, okay, I want to divide this by a red line. The one mathematician said 5 minus 2. I have 5. No, I minus 2. This is like about 1,000 years ago when they did this. Just saying. Okay. Okay, so anyway, 5 minus 2 is 3. So the hunga mingo hoga humba. Well, they didn't talk like that. They weren't cavemen or anything. But anyway, it's 3. And the other guy said, oh, yeah, 5 minus 2 is 3. I can agree with that. So he says, yeah, 3. But, you know, we write it like this. We write it up here, right? So but today, we're going to write it below like this using what I call, well, carrots. Yeah, they don't look like carrots, do they? But I call them carrots. Make them orange for a moment, just so you know. That's what they're called. They call them carrots by convention. Now, but what about this? Unga Munga said, oh, 5 minus 2, 3, and then 3 times 2 is a 6. See how I carrot that? See, this comes from here. All right, and I didn't carrot here, but this 2 came from here. So yeah, and then see, then I carroted it again, 6. And the other guy said, no, no, no. See, my aunt, she's a professional professor at all the, one of the most prestigious universities called Hunga Munga Captain Caveman University. And my aunt says this, 5 minus 2 times 2, you must multiply first. She said, got to do this first. And so this is how Hunga Munga you do it. 2 times 2 is 4. Then you can say 5 minus 4. See, I just put the 5 and the minus sign right there. Now you can say, oh, Hunga Munga answer is 1. See, 1. 1 stone in the Stone Age, not a 6. And he goes, oh, your aunt. Okay, well, she knows her stuff better than me, so Hunga Munga, let's go. Hunga Munga, that's what I thought. Hunga Munga, you're littler than me, so don't mess with me. Hunga Munga, okay. All right, so here we go. Because Mike doesn't make right. That's the moral of this story. Okay, so let's do this one. It says, what about this one? So what about when we, wait, is this something I already did? I already did this. Yeah, Hunga Munga, we did this. So my Aunt Sally said do it this way. Okay, we got that. So this is the rule. Multiply before you subtract. Okay, Hunga Munga, multiply first. Okay, what about this? Oh, just remember, my Aunt Sally, my Aunt Sally said this. Okay, what about addition? Do we still follow the same thing? Yep, still going to do this, because if you didn't, this is what would happen. If we didn't agree on this, we'd all get different answers. And then the mathematicians from back in the day, even though they might be crazy for saying this, Hunga Munga, that's what we've been doing ever since. So that's how we're going to keep doing it, whether it's better or not. We're going to say 5 plus 2 times 2, right? Then times 2. So 5 plus 2 is 7, then times 2. You would get 14, Hunga Munga. No, wrong, Hunga Munga. Here we go. It's going to be 2 times 2 first, which is 4. Then we're going to add the 5. Multiply first, then add. Doesn't matter how they write it and what order they come in. So that's 9. That's correct. So what have we learned so far? Multiply before you add and subtract. My Aunt Sally. My Aunt Sally. Okay. What's next, my Aunt Sally? Hunga Munga, what about division? Do we divide first too? Is it because it's powerful? Powerful division? You can break things in half? Yes. So if you have 2 and you break it in half, you have 1 each. All right, so that turns into a 1. Caret, 1. But if you didn't, this is what would happen. If you didn't, this is what would happen. This guy says, no, we do this first. We add first. That's a 6 divided by 2, and that gives us 3. And Hunga Munga says, no, my Aunt Sally says, you divide first. Divide and multiply before you add and subtract. So this is going to be 1. Now we have 4 plus 1, which is 5, and that's way more than 3. It doesn't mean it right, but that's how we're doing it by convention. So multiply and divide before you add and subtract. My dear Aunt Sally. Thank you, my dear Aunt Sally. What would we do without you? So here we go. Now, 1 times 2. Okay. My dear Aunt Sally. My dear Aunt Sally. says, okay, we're going to multiply, divide, add, and subtract. So do we have any multiplying up here? Yes, 1 times 2. Do we agree on that? This guy says, yeah, I agree. We'll start like that. 1, 2. Then what do we do? He says, well, what I have left is 5 minus, this is the 2 right here. This turned into a 2, plus 2. So I'm going to follow what Aunt Sally said. Your Aunt Sally said, multiply first, then divide. There's no division here, so we don't have to worry about that. But then your Aunt Sally said, add. So I'm going to add next, 2 plus 2. So here we go. 2 plus 2 is 4. And then now I could subtract this 5 minus thing, right? Which is 1. Hunga munga, right? Is this right? Did I do it right? Did I do it right, teacher? If this is the teacher, let's just say. Teacher says, no. My Aunt Sally would not be pleased with this. So let me show you what Aunt Sally would do. Sad, happy, turn upside down face. Smile. Okay, let's figure it out here. You don't want to upset Aunt Sally. So what we're going to do is we're going to say, yes, I agree with the 1 times 2. We do multiply first. Good. Then if we had any dividing, we would do that, but we don't, so we'll skip that. But even though Aunt Sally said to remember what we do, my dear Aunt Sally, we still do this in order from left to right. From left to right. So we're going to do whatever shows up first. And what shows up first? Well, let's rewrite it first. We have the 5 minus, this turned into a 2, and we still have plus 2 over here. So we have to add 2. So when we're going from left towards the right side, this is the right, this is the left, what do we hit first? We hit a minus first. So we're going to minus first, because that's what we hit first, going from left to the right. 5 minus 2 is 3. Now let's keep going. We'll change color just so you know where we left off. Plus 2. Now we have 3 plus 2, which is 5, but I'm going to make a little room because this is getting a little messy. 3 plus 2 is 5, and this is how you do it. This is how you do it. Not like this. So, what have we learned so far? This is showing them side by side. This guy said ended up with this. You do it left to right, even though it says A first. Not necessarily. What comes first up here is what we do first. Get it? These go together. A goes with AS. Aunt Sally goes together. Add and subtract goes left to right. My dear Aunt Sally, but remember this thing here from left to right. As you're going, if you hit the add first, you do add first. You hit subtract first. What if it's subtraction add? You do whatever comes first, going left to right. Same thing with this. Well, while we're at it, what about multiplying and dividing? Well, let's do the same rule, just so we can all come up with the same answers and be on the same wavelength. Okay. Okay, here we go. Consider this. This is going to take you to a whole nother level, so pay attention closely. $2. This kid has $2. Mom gives him $3, right? Together they have $5. Dad says, I have twice as much as both of you put together, right? So we're going to add what Dad has too. And what do we get when we're done with all of that? How much do we have all together, right? So we're going to have to, let's see here. So Unga Munga, we follow my dear Aunt Sally. My dear Aunt Sally says, any multiplication? Yes, there is. Let's do that first. Okay, I can agree on that. I can agree on that. Okay, keep going though, keep going. So that's 3 times 2 is 6. Now what do we have left? We still have this 2 over here. So let's bring it down here. 2 plus 6 is 6 of 8. So he has $8. Something just doesn't seem right about that. I don't know why. Let's see. What does Unga Munga say? Unga Munga, my Aunt Sally. What do you mean your Aunt Sally? I'm getting tired of your Aunt Sally. What now? What's the deal with Aunt Sally? Well, haha, I'm glad you asked. Let me show you. Haha. Okay, my Aunt Sally says when you get a situation like this, because you had the $2 first and the $3 first, and you put them together first, we have to do that first. But Aunt Sally says, my dear Aunt Sally says, multiply, multiply, multiply. But she came up with this thing called parentheses. Parentheses. So we're going to put them in parentheses. Okay. We're going to put these in parentheses. And whatever goes in parentheses, that goes first. Since this is inside the parentheses, we're going to do that first because it makes sense to our story. $2 plus $3. That's going to be a $6. Now, since Dad has twice as much as that, how much does Dad have? We multiply by 2, and that'll tell us something says right here. Am I doing this wrong? Oh, I see what I did wrong. I didn't add right. Oh, Mr. Hoffman. Oh, why do I talk to myself like that? Oh, me. Oh, me, oh, my, oh. I am from Ohio. What do you have guessed that? Okay, so it's 5 times 2. Now I remember. 5 times 2. And that's going to be 10. So how much money does Dad have? He has $10. Now, if Dad puts his money with their money, they have together $5. Together, all three of them will have 15 bucks. Pretty nice if they give it to the kid, right? So the kid started with 2 bucks. He's walking away with $15. Nice. If Mom and Dad will give it to him. We'll see. Here it is again, just for a review. Remember the parentheses. So what do we got so far? Parentheses. This really, the Unga Munga says, oh, another teaching lesson in a couple minutes. Unga Munga says, this really pleases my Aunt Sally. Okay, so parentheses first, then multiply and divide, left to right, then add and subtract, left to right. And what about exponents, the other Unga Munga says. Did your Aunt Sally think of that? Did she? Huh? I want to know. And the other guy says, uh-oh. Oops, no she didn't. Unga Munga, no. So please, the Unga Munga says, excuse my dear Aunt Sally for not thinking of exponents. That's it, we'll do exponents second, Unga Munga. The first Unga Munga says to the teacher. Unga Munga. And he's like, huh? Unga Munga second? Let me show you. Unga Munga first. Parentheses, exponents, my dear Aunt Sally. Please excuse. And the other guy says, oh yeah, please excuse my dear Aunt Sally, I get it. So that's what we're going to do. We're always going to do parentheses first, then any exponents, which we haven't really worked with yet, then multiply, divide, then add and subtract. So let's do a couple of these because you're probably like, oh, how do we apply this? So let's try this one. Please excuse my dear Aunt Sally. Any parentheses? Nope. Any exponents? Oh, yes, there's an exponent right here. So that's really 6 times 6, right? Some of you are thinking, oh, 6 times 2. I know I want to do that too. And the answer is 12. Nope, not it. 6 times 6 plus the 15. 6 times 6 is, now I'm going to bring it back together, 36 plus 15. And I got to do this vertically. I can't do this horizontally. 36 plus 15 is 3, 4, 5, 51. I guess you could do this in your head if you think of this as 11 and this is 40, right? 40 plus 11 is 51. Okay, what about this one? You try it. Oh, how'd you do? This is 5 times 5, which is 25. We still have to add our 20 plus 20, 55. I think get the idea. Let's get to something different. Ooh, this one looks good. FSA challenge zone. The expression 6 to the 3 times 6 to the 4 is equivalent to which of the following numerical expressions? Aha, so 6 to the 3 times 4 to the 2. So let's think. Please excuse my dear Aunt Sally. Are there any parentheses? Nope. Are there any exponents? Yes. So let's do those. We got to do this exponent and this exponent. What do we get? Well, if you were to do 6 times 6 times 6, you would get, see, 6 times 6 is 36. Is 6 times 6 times 6. This is 36 times 6. Oh my gosh, this is a problem, isn't it? Times 6. Yeah, oh my gosh. Oh wait, do I really need to do all this work? Yeah, I probably do. All right, let's keep going. Just in case. All right, so that's 36, 18, 19, 20, 21, 216. Wait, 216? This is 216 times. Oh, already it's looking like this, isn't it? It is that, because what's 4 to the 2? It's just 4 times 4. So I know it's getting messy here. I'm so sorry. So let's bring down the 216 times, and what's 4 times 4 is 16. Yeah, and to do that, oh, that'd be crazy. We don't have to. They have it right there. So the answer is no, 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 no. D D D D D D D D D D D. Oh yeah, just for fun. Hunga munga. All right. Ooh, look at this one. How would you do this? Are there any parentheses? Nope. Any exponents? Nope. Any multiplication? Yep. Yes, sir, Bob. Yes, sir, Joe. Yes, sir, whoever you want to say. 2 times 3 is 6. Let's bring everything else down. 8 minus 6 plus 7. Now what do we do? Any division? No. Any adding? Yeah, but remember, add and subtract go together. So you got to go from left to right. Whatever you hit first. So when we're going from left to right, what do we hit first? We hit a subtraction first. So we're going to subtract first, which is 2. Then we can add. 2 plus 7 is 9. Be careful with this one. Be very, is 2 R's or 1 R? Careful. Oh, I think that's 2 R's. No, I think it's 1 R. Okay. Oh, you try this one. Yeah, I'm not doing this one. You can do it. What about this one? It's the same thing. You're just going to do this first and then go left to right. Oh, here's something a little different. Oh, what did I do? Back there, there you go. Parentheses first. Are there any parentheses? No parentheses. Any exponents? Yes, right here. Let's do that. 4 to the 3 is 4 times 4 times 4, which is 16 times 4, because 4 times 4 is 16, and we still have a 4 there. And oh, really? Do I have to do this 16 times 4? This is a lot of fun. This is a lot of fun. I was about to say work. I'm thinking, no, it's not. It's fun. Just trick yourself. It's fun. Yay. Fake it till you make it. 6 times 4 is 24. 4 times 1 is 4 plus 2 is, 64? Should I have known that? 24. Yeah, 64. So this is 64. Now we still have plus 4. See, I'm going to show you. We still have this plus 4, and we also have this times 5. So I'm writing down the plus 4, and I have to write down the times 5 right here. Times 5. Now what do I have to do next? Are there any? Let's keep going. So we did exponents. Is there any multiplication and division? Because remember, those go together. My dear, Aunt Sally. You got to say, please, excuse, my dear. See how we did that together? Aunt Sally. Try it like this. Please, next, excuse, next, my dear. See how they go together? Multiplication, division. You could say, dear my, if you want, because it could be division first, whatever comes first. In the order that it appears, going from left to right. And it's to add, subtract, Aunt Sally. Or you could say, Sally Aunt. In some net languages, they say that first, Sally Aunt, right? Sally, how do you say uncle? Oh gosh, I used to know how to say uncle in Spanish. I can't believe I can't remember it. Maybe next time. Okay, anyway. So now we're going to do the multiplication first. See, that comes next. Let's see, let's get rid of these colors because that's throwing me off a little bit. There we go. So multiplication comes next right here, which is 4 times 5, which is 20. So bring my caret 20, and I still have the 64 here, so I'm going to put it here. 64 plus 20 is 60, 70, 84. 84. Same idea. Same idea. Oh, I don't want to do this one. You would, here, I'll just tell you what you do. I'm not doing it. You can do the exponent first, whatever that is, put it here. Then you're going to do the multiplication. So here, I guess I would have to do it. I'm not doing it. I think I'm done. I think you guys got this. I'm not doing all these problems. Ooh, challenge. Yeah, this is high level stuff. See, because with that fraction there, yeah, then you have to that's pretty high level. Okay, that's it. Choose to be. And by the way, I'm not Miss Gonzalez, but I stole this from her. She made this, so yeah, I don't get it. I don't get it. This Miss Ward. Mr. Boone don't get it. Miss Gonzalez don't get it. And now we have Miss Oringer. She's next. She ain't gonna get it either. Watch. You wait.